With the present video, we are going to start the NCERT solutions in physics class 12. 042 you know is physics code in Cbse class 12. We are starting with chapter 1, electric charges and electric field. Let me explain this. Here first letter L, the 12th letter of English alphabet, signifies the class 12th. These two digits 01 up chapter 1 and 01 is the video number 1 for this chapter. Before we actually start with the solution of the problems, here are some useful tips for you. Whenever you have to solve a problem in physics, it's very important to read the question very carefully, identify the known and the unknown quantities. Remember, half your job is done if you understand the problem very well. Record the quantities which are given, convert to SI units if necessary. For example, if distance is given in centimeters, must convert it into meters, that is SI units. Identify the unknown quantities, means what you have to calculate, what you are asked to find out in the numerical problem. Write the appropriate formula. This formula must correlate the unknown quantity with the given quantities. That makes it relevant formula. Substitute the values of the given quantities and calculate the unknown. Write the result with appropriate units. That is a must, because wrong unit means you lose marks in the examination. Let's have a look at question number 1. What is the force between two small charged spheres having charges of 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb, placed 30 centimeter apart in air? Let's analyze. Here the force is the unknown quantity. Small charge sphere means you can take the charges as point charges. The two charges, you will name them as Q1 and Q2. The separation or distance r between them is 30 centimeter, and we will have to express this distance in meters. Now let's record the data. Here is a question for your reference. For solution, first thing is record the data. This is Q1, first charge is Q1, 2 into 10 to the power minus 7 coulomb. The second charge, 3 into 10 to the power minus 7 coulomb, is Q2. Separation is 30 centimeter, and expressed in SI system, it comes out to be 0.3 meter. The unknown quantity here is the force. So we have to write an expression which relates force with the charges. We know that force is given by 1 over 4 pi epsilon naught Q1 Q2 over r square. Remember, here you have the charges placed in air, so we have used the term epsilon naught here, which is constant or electrical permittivity for air. Substituting the given values, this 1 over 4 pi epsilon naught is 9 into 10 to the power 9 Q1 Q2 over distance square, that is 0.3 square. Solving this is a simple calculation, because 3 into 3, 9 will cancel out. You will be left with 3 into 2, 6. The force comes out to be 6 into 10 to the power minus 3 Newton, and it is a repulsive force because the charges are like charges or similar charges, both are positive charges. Question number 2. The electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between the charges? So this tells us the unknown quantity. We have to find the separation. And what is the force on the second sphere due to the first? What is given is force on first sphere due to the second. Once again, the spheres are given to be small. Small sphere means we'll again take the charges as point charges. This is Q1, Q2 negative charge, and the force is 0.2 Newton. Hence the force is attractive because the charges are unlike charges. Again, you have the question statement for reference in this part. We are given Q1, Q2. Q1 is 0.4 microcoulomb. Expressed in coulomb, it is 4 into 10 to the power minus 7 coulomb. Similarly, Q2, and the force is given to be 0.2 Newton. Force is in air, which again means we will be using the same constant 1 over 4 pi epsilon naught for vacuum or air because the two values happen to be the same. So the formula, force in air 1 over 4 pi epsilon naught Q1 Q2 over r square. The unknown is r, so we just have to rearrange the formula. R square is 1 over 4 pi epsilon naught Q1 Q2 over force in air. So substituting the various values, we get r is equal to square root of this 9 into 4 into 4 into 10 to the power minus 4 root. Square root of 9 is 3, 4 into 4 you get 4, and 10 to the power minus 4 gives you 10 to the power minus 2 meter. So the separation is 0.12 meter. For the next part, B part, you have to find the force on second sphere due to the first. We know action and reaction are equal and opposite. So by third law of motion, Newton's third law of motion, we have force on charge Q2 due to Q1 equal to force on Q1 due to Q2. This force is given to be 0.2 Newton. So the force on second charge due to first will also be 0.2 Newton, but in opposite direction. That is, the force will once again be attractive. You can subscribe to our YouTube channel titled Cbse 042. Thanks for watching.